Okay. Today we are looking at 11.6. It is called the combined gas laws. So you know what the word combined means, so we're going to kind of walk through this, see if you can figure this out without me telling you. All right, so we've been learning about Boyle's, Charles, and Gay-Lussac's law. So Boyle's law, we know, is P1 V1 equals P2 V2. I'm going to put that up there. There we go. We know that Charles' law is V1 over T1 equals V2 over T2. And we know Gay-Lussac's is pressure, initial pressure over initial temperature equals final pressure over final temperature. Okay, so looking at these three, what do you think the combined gas law formula looks like? So I'm looking at these, I know I'm dealing with pressure, volume, and temperature, and I'm combining, it's called a combined gas law. So I'm assuming that I'm combining all three of these laws. What would a formula look like if you were to combine these? Now normally students will sit and they'll think about this for a little bit, but I normally always have at least one that can come up with what the formula should look like for this. So I would give you guys a second. I would have you guys kind of write some things down in this area right here. And then we would normally, like I said, there's at least one student that comes up with this. So if you look, I can see that I have P1 and V1 over P2, and that's like over 1. All right, I can see that my volume and my pressure is always on top here. I notice that temperature is always on the bottom, like division. So what you get is you get P1 V1, like it shows in Boyle's law, but now you just put it over temperature. And it's going to equal P2 V2 over temperature. So this is if we have all three of these at play here. Now in the past what we've done is Boyle's law, it's like pressure, volume, we are not changing temperature at all. But now we're saying we have pressure and volume and maybe we do change the temperature a little bit. All right, so let's do a learning check. It's very similar, it's the exact same thing, we're just plugging numbers in. It's just now instead of 3 of 4 numbers, we're now getting 5 of 6. All right, so let's look at this. A sample of helium gas has a volume, right away I'm like, there's my V1, of 0.180 liters, a pressure, there's my P1, 0.8 atm, and a temperature, there's my T1, of 29 degrees Celsius. Now remember, we have to have Kelvin, so that is really 302 Kelvin. At what temperature? So right away I know I'm looking for my final temperature. Will the helium have a volume of 90 milliliters? Now, right away, and students a lot of times tend to miss this. They see a number and they're like, oh, there's a volume, it's V2. Right away, I'm like, my volumes are not the same, so I'm going to change that milliliters to liters. So how I do that is I could do this, and this might confuse you, and it's been a while since we've done this, but there are 1,000 milliliters in 1 liter. 1,000 means a million means 1,000th. So it's 1,000th of a liter, so it takes 1,000 of them to make a liter. So when you do that though, you're dividing, right? It's just making it smaller. So I'm going to move this decimal 3 times. So this is 0.09 liters, and that is my V2. Right? So if I took 90 divided by 1,000, it would tell me it's 0.09. So anytime I see milli, I'm just going to move that decimal 3 spots to the left. Now my pressure, a pressure of 3.2 atm. Now you need to get in the habit of looking. Do these match up? And they do. They're both atm, so we're good. All right. Now I'm going to start plugging all these numbers into this. So I have my initial pressure is 0.8. My initial volume is 0.18. My initial temperature is over here at 302. Remember to use Kelvin. My final pressure is 3.2. My final volume is 0.09. And I'm looking for T2. So now what I'm going to do is I'm going to cross multiply. So wherever this guy is, whatever I don't know, this temperature, I'm going to leave that alone that side. I'm going to cross multiply the side that has all the numbers. So what I get here is I get 302 times 3.2 times 0.09, and that is 86.976. How to get rid of that? There we go. Equals. Now I'm going to cross multiply this side. And I have 0.8 times 0.18, and that is 0.144. All right, now to get temperature by itself, I am going to divide by 0.144 on each side. And let's see what that is. 86.976 divided by 0.144, and that is 604 Kelvin. Now if I asked for this in Celsius, I would subtract 273 and be like, oh, it's 331 degrees Celsius. All right. You can do all of these steps. You don't have to write this out if you don't want to, this part right here. You can do it all in your calculator at once. I'm okay with that. Just make sure you write down. You write this part down so I can see and make sure that you've set everything up okay. All right, the second learning check. More at the end here. All right, the second learning check. A gas has a volume of 675 milliliters. I'm going to change that to liters right away. Well, they want it in milliliters, so I'm going to leave it there. I'm going to leave it like this. So there's my volume. Here's my temperature. So I need to add 273 to that, which is 308. And it gives me a pressure of 0.8520 atm. What is the volume? So V2 is what I'm missing here. Of the gas at negative 95, so I'm going to take 273 minus 95, and that is 178. So you could have said negative 95 plus 273, whatever. And then here's my new pressure. Once again, we need to make sure that everything is matching up, and look, it is not. So it does not matter which one you change. I can change the 0.85 or I can change the 802. I'm just going to go ahead and change the 802. So I'm going to do 802 millimeters of mercury, which means millimeters of mercury on bottom, ATM on top. 1 ATM equals 760 millimeters of mercury. I'm just doing this because I like to work with smaller numbers. So that's why I chose this way. All right, this is going to be 1.06. I'm not real picky on where you round out on those. But this is my P2. All right, so now I'm going to plug all this in. I've got 675 volume and pressure go on top. My temperature on bottom. And I'm going to put, I don't know my volume, but I know my pressure is 1.06. Don't know my pressure, and I know that my new temperature is 178. Now I'm going to cross multiply. So 675 times 0.8520 times 178 is 102,367.8 equals, and now I'm going to do this side. So 308 times 1.06 equals 326.48. There's my P2. So to get my pressure by itself, I'm going to divide by 326.48 on both sides. So I'm going to take 102,367.8 divided by 326.48. And running out of room here, it's 313.5, and this is pressure. Or I'm sorry, this is volume. I'm sorry, guys. This should be V2. You hadn't caught that already. So this is volume, and this is going to be milliliters. This V2. Okay, so after they do that, they are going to have a worksheet to work on. So we'll go over this. It shouldn't take the entire class period. And then after that, they're going to have, let's see here, section 6 worksheet. Right here. It's nothing too big. It's just got a few problems on here, if you notice that. It's just, number one, how did we get that combined gas law? And then number two and number three are just some problems, all right? So nothing too bad there. It'll be participation. Let me know if you need anything. Have a good day.